Hi everyone, my name is Minsoo Thigpen, and I'm a senior PM at Microsoft in the Azure Machine Learning platform working on responsible AI tooling. I'm joined today by my colleague Mehrnoosh Sameki, who is a principal PM lead of responsible AI tooling in Azure AI. Today's talk, we're very excited to tell you about how you could take something that's quite a buzzword, responsible AI, and take it from principle to practice, and how to implement that using open source tooling. And if you wanted to take it to the cloud, what are some options there that Azure could provide you? So our agenda today includes an introduction to the responsible AI principles, how to drill down into those in the tools that can be found in open source that we've released in the recent past. We'll give you a short demo and then we'll open it up for a QA. So why responsible AI? This quote from the Tools and Weapons, written by Brad Smith and Carol Ann Brown in September 2019, sums up the point quite well. So when your technology changes the world, such as the tech companies have done, you bear a responsibility to help address the world that you have helped to create. AI is here today, all around us. It's ubiquitous, and it makes our lives more convenient, productive, and even entertaining. It's finding ways into some of the most important systems of everyday affairs, in politics, in law, and it affects us as individuals across our lives in many different industries such as healthcare, finance, education, and employment. Organizations have recognized that AI is poised to transform business and society. The advancements in AI, along with the accelerated adoption, are met with evolving societal expectations and growing regulation in response. AI is complex because it's not a single thing, but a constellation of technologies that can be put to many different uses with vastly different consequences. It has unique challenges that we need to respond to, and to take steps towards a better future, we need to define new rules, norms, and best practices. So, AI regulation is coming, and these are some of the places where you have enacted regulation as well as proposed regulation, and we don't see that stopping anytime soon. On a weekly basis, there are new headlines highlighting some concern regarding the use or misuse of AI. As societal expectations are growing, more members of our society are considering whether AI is trustworthy and what companies are innovating with their concerns in mind. We're showcasing the 6 core ethical recommendations in the Future Computed that represents Microsoft's view on AI. The first principle here is fairness. For AI, this means the AI system should always treat everyone fairly and avoid affecting similarly situated groups of people in different ways. The second principle is reliability and safety. To build trust, it's also important that AI systems operate reliably, safely, and consistently under normal circumstances and in unexpected conditions. It's also crucial to develop AI systems that can protect private information and resist attacks. As AI becomes more prevalent, protecting privacy and security of important personal and business information is becoming more critical and complex. For the 1 billion people with disabilities around the world, AI technologies can be a game changer. AI can improve access to education, government services, employment information, and a wide range of other opportunities. Inclusive design practices can help system developers understand and address potential barriers in a product environment that could unintentionally exclude people. By addressing these barriers, we create opportunities to innovate and design better experiences that benefit everyone. When AI systems are used to help inform decisions that have tremendous impact on people's lives, it's critical that people understand how these decisions were made. A crucial part of transparency is what we refer to as intelligibility, or the useful explanation of the behavior of AI systems and their components. And our final principle is accountability. We believe that people who design and deploy AI systems must be accountable for how their systems operate. This is perhaps the most important of all the principles. Ultimately, one of the biggest questions for our generation, as the first generation that is bringing AI to society, is how to ensure that AI will remain accountable to people, and how to ensure that the people that design, build, and deploy AI remain accountable to everyone else. So here are the 6 guiding principles to responsible AI that we just covered. And we're going to double click into 3 of them and where tooling can help us. We need building blocks to enact on our principles. A multifaceted approach is needed to operationalize principles at scale. And here are the 4 key areas that we want to focus on. At the foundation, we have a governance structure to enable progress and accountability. Then, on top of that, we have rules to standardize our responsible AI requirements. Then you need to take your whole org along and create training and practices to promote a human-centered mindset. And finally, you need to have the tools and processes for implementation. So if we double click into the tools and processes, here's where we can help. We can help with the principle of fairness in the reliability and safety of your AI systems, as well as the transparency of your AI systems. We've already had some open source key tools that you are all familiar with, such as FairLearn, Interpret ML, and error analysis that we've released in the recent past, along with an all-up dashboard called the Responsible AI, which brings all of these tools and many others together in one place for you to have a one-stop shop of analyzing your machine learning model. That also, we not only have released these tools in open source, as you can see here, we also have integrated them into Azure Machine Learning, which is Microsoft's AI development platform. Azure Machine Learning serves as the foundation for this paved road so that our customers will benefit from our development of engineering systems and tools and best practices too. Now, jumping back into the Responsible AI dashboard, which we said was this one-stop shop where you would be able to analyze your machine learning model, we've broken this into 3 separate steps. We have identify, diagnose, mitigate, as well as an additional component of making decisions in real-life scenarios and real-life policy interventions. So we'll be going through each of these columns of tools where you would be able to use them in this part of the process. And then we will move forward to a demo, which I will hand off to Mehrnoosh. First, we have Identify, which we're going to be able to use the error analysis tool and the fairness tool within the Responsible AI dashboard. How many times have you seen in articles or recently published research papers that a model is 90% accurate? It's a single score accuracy or aggregate number that is describing the performance on a whole benchmark. The challenge here is that this aggregate number can hide very important conditions of failure, where the model may be underperforming for a particular subset of your data or some population groups. For instance, an HR model might be 90% accurate, but when you dive deeper, you realize it's only 50% accurate for employees of age greater than 45. They give the impression that model accuracy is uniform, when we know that in the real world it is not. So that being said, discovering pockets of data with high error discrepancy can be tedious and time-consuming, and requires a streamlined infrastructure for error detection, which error analysis is able to provide. Then we also address fairness in AI, which addresses 2 separate types of harm: quality of service, where a system works well for one person as it does for another. The example of a quality of service harm is when a facial recognition system might not be able to recognize a woman of color, but is able to recognize a white male. Then we have the harm of allocation, which is the harm that occurs when AI systems extend or withhold opportunities, resources, or information to specific groups of people. The example we have here for a job applicant is that maybe these job opportunities are not being shown to women for being a doctor, but maybe they might be seeing job opportunities for only nursing. Then we go into the process of diagnosing, right? We identify where the error or failures might be happening in the model. Then we want to diagnose and understand why these errors are happening. And we're using interpretability, counterfactual what-ifs, and data exploration here in order to do that. Interpretability is helping you to understand overall, why is my model predicting the way it is? And it tells you the top K important factors impacting your overall model expectations or predictions, as well as telling you for, Mehrnoosh, what are the top K important factors impacting the model's predictions for her. Then we have counterfactuals, which helps you to debug model predictions by creating these sets of counterfactual what if data points that is perturbing the data point just enough in order for it to cross the threshold of getting accepted for a loan if Mehrnoosh was rejected for a loan initially by the model. And so we could say, okay, Mehrnoosh, maybe there's a version of you where you increase your income by $1,000 or $10,000, and then the model will be able to predict you as being accepted for a loan. Then finally, we have mitigate and take action, which we use the fairness toolkit as well as data augmentation and causal inference. You can mitigate fairness issues with state-of-the-art algorithms for specifically your classification and regression tabular models. And you can access these mitigation techniques through the FairLearn open source data package. And you can also use causal inference, which is part of the Responsible AI dashboard, to understand the overall causal effects of your data points on a certain outcome that you might be interested in. So, for instance, you can see overall what are the specific features that impact your outcome in the real world scenario, as well as for Mehrnoosh, what are the specific features that will impact her outcome the most in order for you to make an intervention or a policy treatment there. And that is something that we also provide for you in the Responsible AI dashboard. So now I'll be handing this off to Mehrnoosh to show us a quick demo of the Responsible AI dashboard. Thanks, Mehrnoosh.
Thank you, Minsoo. So here we would like to show you the Responsible AI dashboard in action. I do have a classification model which is predicting whether employees would leave or would stay with the company. And I would like to essentially bring the Responsible AI dashboard to help you debug this machine learning model. Upon loading this dashboard, you're going to see multiple different capabilities of this dashboard. If I show you here, you're going to see all these functionalities. So for instance, I have activated error analysis, model overview, data analysis, feature importance, and counterfactual analysis in this particular one. And so upon loading, I land on error analysis. I can take a look at how errors are distributed in my machine learning model. And so for instance, that gives me an indication that for this certain group, which is employees total working years less than 7.5, 61% of overall errors are laser focused in this cohort, and this cohort has 21% overall error rate, versus the other cohort, which if I click on is people with total working years greater than 7.5 years. For them, only 8% errors are happening in this particular node. So maybe I can save this as my kind of like more success cohort, total working years greater than 7.5, and the other one I can save as the more erroneous cohort. And I would like to know why my model is making systematically different errors for employees with different total working years. So I saved that as well. One other thing that I could do is click on feature list, and that gives me an indication of what are the top factors impacting this prediction of this machine learning model errors. So what factors are more contributing to the errors in this AI? And training time since last year, job role, total working years, these are the top ones. And so that gives you an indication of maybe you can look into different buckets of these features and try to get a sense of whether you're representing different groups with different labels of leaving or staying well in your training data. So that gives you an indication of what is causing these errors. You can also click on heat map and take a look at your errors distributed across the board, or you could create brand new cohorts by clicking on new cohort. So if you're curious about employees of certain gender, certain ethnicity, certain age, certain years since last promotion, you can also create your own cohorts here and then save those groups. And what that gives you is then it's kind of like a waterfall style. As you move towards the rest of this dashboard, all the cohorts that you create, either from the error tree or the heat map or from freeform new cohort creation, are transferred and you can compare them. So for instance, as you saw, I saw that the total working years less than or equal 7.5 are getting worse accuracy. That is something that I would like to investigate further, but I see a confirmation of that here. I can also see different charts on these 3 cohorts of all data on the 2 that I created and save it for my stakeholders to explore. I can also click on feature cohorts, which aims to give you a disaggregated analysis of your features. So for instance, you're curious how people of different age groups are receiving treatment from the AI, and you could see that the youngest age group, age less than 32, is having the worst accuracy. And that's something that, again, we could explore. Or the other thing that you could see is you could also do intersectional fairness analysis. So now you're interested to see an intersection of gender and age. What are the groups that are getting the worst treatment? And it seems like the youngest male group employees are getting the worst accuracy. So that's another thing that you could explore. And so I might just create some cohorts of age less than or equal 32, just for exploration of why that group was getting a very low accuracy. And in contrast, I can also create another one, which is age greater than 32. And I just name it in a way that I can detect. And as you can see in the dataset cohorts now, these 2 are also transferred, and I can see that the age group less than or equal 32 is also almost getting 10% less accuracy point than the other one. Now I'm coming to the data analysis, and you can see your chart view, table view. You can take a look at, the correct predictions or incorrect prediction in case you want to just inspect them visually. But also in the chart view, you can look at the statistics of your data. So for instance, I'm curious to see the ground truth representation across the board. So I choose count and ground truths on my X and Y axis. And then I click on age group less than or equal 32, which if you recall had a lower accuracy compared to age group greater than 32. And one thing that I noticed is in age group greater than 32, most of the people have actual ground truths of staying. So even if my model randomly and completely randomly says that these people are going to get prediction of staying, it's going to achieve a higher accuracy versus for age group less than or equal 32, I have a better balance, but since the dataset is small, it never learns how to distinguish and differentiate between young people leaving versus staying. And so one action item for me is in both of the age classes, try to collect more data of representative of staying and leaving and retrain the model. Same is true for this error cohort. If you compare with the other one, in the other one I have a very imbalanced case. So even if the model randomly says people are going to stay, it's going to achieve a higher accuracy versus here I have a little balance, but the data set is small. So again, collect more data. Maybe even if you don't have data, try to use some synthetic data. And I'm going to introduce one library that could help with that right after. Then I'm coming to feature importance. For simplicity, let me turn off all other cohorts. That gives me an indication of first, overall explanation. What are the top key important factors impacting models predictions? So for instance, I can see that overtime is the top most important factor. Now I'm curious in what direction. I click on it and I ask it to show me the impact of overtime towards prediction of leaving. And so it gives me that indication that for those people who have been working overtime, so overtime feature is yes, that becomes a positive indicator towards prediction class leaving, versus for those employees not working overtime, that becomes a negative factor towards prediction leaving. And I can similarly click on all of these other bar chart features and see how they impact the overall prediction. And I could take a look at individuals as well. So for this person, what are the top key important factors positively or negatively impacting his or her predictions specifically? Finally, you can land on counterfactual analysis, which first can give you free-form what-if analysis for any data point where you can perturb features and see how the prediction changes, but it can also give you counterfactual analysis, which are what are the closest data point with the opposite outcome, or in other words, what is the bare minimum change you can apply to one particular data point's features in order for the model to say the opposite outcome for it. So here I clicked on one particular instance. This person has been predicted to leave, which interestingly in this data set is class 0. And you're interested to see what could be different, like bare minimum changes different for this person, so that the model says the opposite, predicts this person to be staying. And so I click here, I can see that this is the person, has been predicted to leave, has an income of this much, is the job involvement, and dash means no change. So now I'm giving you 10 different alternative options or counterfactuals for this one, where they have been predicted to stay with no changes to anything, just increasing this person's job involvement to 5 and increasing the monthly income from this to this person is going to get the prediction of staying. Similarly, if for example the job involvement was from 2 3, or if the person was not working overtime, even if the salary and other stuff won't change, this person is going to get the prediction of staying. So this is a great way for you to just double check how the model is making its decisions, whether that makes sense, based on the factors that intuitively you think should be important here. And also you can do free form perturbation. You can change his or her job involvement, overtime, monthly income, and whatever else, and save that as a new data point. With that demo out of the way, I just want to introduce 2 new tools that we also released around 2 months ago. And one of them is called Responsible AI Mitigations, which is a Python library for implementing and exploring mitigations for responsible AI on tabular data. This particular tool fills the gap on the mitigations end and is intended to be used in a programmatic way. And the other new tool is Responsible AI Tracker. It's a Jupyter Lab extension for tracking, managing, and comparing responsible AI mitigations and experiments. In some way, the tool is also intended to serve as the glue that connects all these pieces together. Both of these new releases currently support only tabular data, and now I would like to hand off to my colleague, Mehrnoosh, principal researcher from Microsoft, to show you a demo of how these 3 tools could come together and could be pulled together to help you debug your machine learning lifecycle.
Responsible AI Tracker is an open source extension to the Jupyter Lab framework and helps data scientists with tracking and comparing different iterations or experiments on model improvement. Jupyter Lab itself is the latest web-based interactive development environment for notebooks, code, and data for Project Jupyter. In comparison to Jupyter Notebooks, Jupyter Lab gives practitioners the opportunity to work with more than one notebook at the same time to better organize their work. Responsible AI Tracker takes this to the next step by bringing together notebooks, models, and visualization reports on model comparison, all within the same interface. Responsible AI Tracker is also part of the Responsible AI Toolbox, a larger open source effort at Microsoft for bringing together tools for accelerating and operationalizing responsible AI. During this tour, you will learn how to use Tracker to compare and validate different model improvement experiments. You will also learn how to use the extension in combination with other tools in the toolbox, such as Responsible AI Dashboard and the Responsible AI Mitigations Library. Without further ado, let me show you how this works. Here I have installed the Responsible AI Tracker extension, but I have not created a project yet, so let's create a project together. Our project is going to use the UCI income dataset. This is a classification task for predicting whether an individual earns more or less than 50K. It is also possible to bring in a notebook where perhaps you may have created some code to build a model or to clean up some data. So that's what I'm doing right now. Let's take a look at the project that was just created and the notebook that we just imported. Here we're training on a split of the UCI income dataset, and we are building a model with 5 estimators. It's a graded boosted model, and we are also doing some basic feature imputation and encoding. After training the model, we can then register the model to the notebook so that in the future we can perhaps remember which code was used to generate the model on the first place. So we just pick the model file, we're going to select the machine learning platform, in this case sklearn, and the test data set where we want to evaluate on. Next, we're giving a few more information items related to the formatting and the class label, and then we're going to register the model. We see that the overall model accuracy is around 78.9%, but this doesn't give us yet enough information to understand where most errors are concentrated on. So to perform disaggregated model evaluation, we are going to use the Responsible AI dashboard. And this is also part of the Responsible AI toolbox. It's a dashboard that consists of several visual components on error analysis, interpretability, data exploration, and fairness assessment. The first component that we see here is error analysis. This visualization is telling us that the overall error rate is 21%, which coincides to the accuracy number that we saw on Tracker. And next, it's also showing us that there exist certain cohorts in the data, such as, for example, this one, where the relationship is husband or wife, meaning that the individual is married, for which the error rate increases to 38.9%. And at the same time, for individuals who are not married, on the other side of the visualization, we see that the error rate is only 6.4%. We also see other more problematic cohorts, such as, for instance, individuals who are married and have a number of education years higher than 11 years, for which the error rate is 58%. To understand better what is going on with these cohorts, we are going to look at the data analysis and the class distribution for all these cohorts. In overall, for the whole data, we see that there exists a skew towards the negative label. There exist more individuals that earn less than 50K. But when we look at exactly the same visualization for the married cohort, we see that the story is actually more balanced here. And for the not married cohort, the balance looks more similar than the prior on the overall data. And in particular for the cohort that has a very high error rate at 58%, married and number of education years higher than 11, we see that the prior completely flips on the other end, and there exist more individuals in this cohort that earn more than 50K. So based on this piece of information, we are going to go back to Tracker to see if we can mitigate some of these issues and also compare them. So let's now import yet another notebook that performs a general data balancing approach, and we are going to import this from our tour files in the open source repository. These data balancing techniques, basically what it's doing is that it is generating the same number of samples from both classes, the positive and the negative one. And if we see how the data looks like after rebalancing, we can see that the full data frame is perfectly balanced. However, more positive labels have been sampled from the married cohort, and that is probably because the married cohort initially had more positive examples to start with. So after training this model, we can then register the model that was generated by this particular notebook, and here we can bring in the model, we can register exactly the same test data set so that we can have a one-to-one comparison. And we give in the class and see how these two models compare. We can see that in overall data balancing has helped, the accuracy has improved, but we want to understand more. We want to understand how the trade-off between accuracy and precision plays off. And indeed, we can see here that even though the overall accuracy has improved by 3.7%, precision has dropped by a large margin. And when we look at the merit and not merit cohorts, which are the ones that we studied earlier with the Responsible AI dashboard, we can see that indeed most of the improvement comes from improvements in the merit cohort. However, we also see that a lot of the precision has declined in the merit cohort, which brings up the question of whether this type of balancing that is more like a blanket and general approach has hurt the precision for the merit cohort, mostly because most of the positive data was sampled from this one. So then the question is, can we do this in a more custom way? Can we perhaps isolate the changes in data balancing between the two cohorts so that we can get the best of both worlds? And there are two ideas that perhaps come in mind here. One of them could be, well, we can perfectly balance the two cohorts separately. And the other idea would be perhaps to balance the merit cohort, but since the not merit cohort has a good accuracy from the start, maybe it would be better to not make any changes. We will try both here, and both of these notebooks are available in our open source repository. I'm going to upload both of these in the project now, the one that balances both cohorts and the one that leaves the not merit cohort unbalanced. And we are going to talk about this as the targeted mitigation approach. So first, let's see how we have implemented both of these mitigation techniques using the RAI mitigations library. In particular, we are going to use the data balancing functionalities in the library. And here we see that we have created the cohorts. The first cohort is the merit cohort, and the other one is the complement of that. And in this case, this coincides with the not merit cohort. And we have defined two pipelines, one for each cohort. And through the cohort manager class, we can sort of assign which pipeline needs to be run in an isolated way for each of the cohorts. And we see that basically these are doing the same thing. They are resampling the data so that in the end we have equal frequencies of each of the classes. And this is how the data looks like after the rebalancing. The overall data is perfectly balanced, and so are the two other cohorts. And the other mitigation technique that we are going to explore here is to apply rebalancing only for the merit cohort, because this is the one that had higher errors on the first place. And for the second one, we are giving an empty pipeline. And this is how the data looks like after this mitigation. The merit cohort is perfectly balanced, but we have not touched the distribution for the rest of the data. And after this, we are going to compare all of these models together, and we're going to compare them across different metrics, but also across the cohorts of interest. So after registering the new models that we just trained with the two new mitigation techniques, we can then go back to the model comparison table and see how the model has improved in all these cases. So first, let's compare the strategy where we balance both cohorts separately. We see that this type of mitigation technique is at least as good as the baseline. However, most of the improvement is focused on the merit cohort, and we see a sudden drop in performance for the not merit cohort. Often we refer to these cases as backward incompatibility issues in machine learning, where we see new errors being introduced with model updates. And these are particularly important for real-world deployments because there may have been end users that are accustomed to trusting the model for certain cohorts, in this particular for the not merit cohorts, and by seeing these performance drops, this may lead to loss of trust in the user base. So this is the story for the mitigation technique that balances both cohorts. For the next mitigation technique, where we saw that we could target the data balancing only for the merit cohort and leave the rest of the data untouched, we see that in overall there is a 6% improvement, which is the highest that we see in these set of notebooks, but at the same time we see that there are no performance drops for the not merit cohort, which is a positive outcome. And of course there is good improvement in the cohort that we were set to improve in the first place for the merit cohort. And the precision is higher than in the blanket approach, where we just balance the whole data. So in this way, we can get like a good picture of what has improved and what has not improved across all models, across different cohorts, and across different metrics. And we can create more cohorts by using the interface. For example, earlier we saw that the performance drops were mostly focused in the cohort of merit individuals and who had a number of education years that is higher than 11. So we're trying to bring in that cohort now and see what happened to this one. And here we are adding the merit relationship as a filter, and then we are going to add another filter that is related to the number of education years, and we want this to be higher than 11. So let's save this cohort and see what happened here. So we saw that initially the accuracy for this cohort was only 41.9%, and through the different mitigation techniques, we're able to reach up to 72 or 73% by targeting the mitigation to the types of problems that we saw in the first place.
Thank you, Besmira. One thing that I would like to note is even though Responsible AI Toolbox is an open source offering, the Responsible AI dashboard has been integrated within Azure Machine Learning and is generally available, and you could use it with YAML-powered workflows, CLI, SDK, and also a no-code on-demand UI in order to generate a debugging experience around your machine learning models. And not just that, you could also generate a new offering called Responsible AI Scorecard, currently in public preview in Azure Machine Learning, in order to summarize the insights that you just observed in the REI dashboard in a PDF report and share that PDF report with your technical and non-technical stakeholders. Thank you so much for being with us and paying attention to this presentation. And these are some resources where you can find out more about our offerings. And you're always more than welcome to reach out to us via LinkedIn as well. Thank you.